Hello students, welcome to the channel of Parallax Tutorial. My name is Pallabi and today we are going to continue with the fourth video on the series of topic-wise past paper questions of IB AAHL Mathematics Paper 1. This is a no calculator paper. The topic we are currently doing is functions. Today, I will be solving a question with two subparts. The concept of mathematical induction and its applications is explained in detail in the second subpart of the question. So pause the video and take down notes if required. Okay, so let's begin. So as you know, the topic is functions. The first question is of it's a 3-marker. And it says the function is given already. F of x is x by, let's write it over here. F of x is x by 2 minus x for 0 less than equal to x less than equal to 1. We have to find the expression for f of x, which is a composite function. So f of x means, now, how do we solve these questions? I know these create a lot of confusion amongst the students. So what you need to do over here is, in place of x, you have to plug in f of x. That's all in your new composite function. So it's also a function. Try to understand this. This is a function f of x, which is given like this. You are supposed to find f of x, which is another function called a composite function, right? In that, instead of x, you have f of x as your independent variable, right? Okay, let's begin. So over here, if we plug in, see, the original function was x, but in place of x, now we will put the whole thing. So it's x by 2 minus x upon, in place of x, we have put that 2 minus, in place of x, again, we will put x by 2 minus x. That's what we do. Now, this is paper 1. Paper 1 means you are not allowed a calculator in this paper, right? So, you cannot use a calculator, obviously. So, let's begin. So, the top part will be x by 2 minus x, and let's take the bottom part. So you take the common denominator, which is again 2 minus x, and the numerator would be 4 minus, so 2 into 2, 4 minus 2 into x, which is 2x, then a minus x, right? This and this gets cancelled. You're left with x by 4 minus 3x, which is f of x, f of x, my bad, or this. It is basically x by 4 minus 3x. Okay, now moving on to the next part, which is the more important part. It holds 8 marks, so it's going to be long. Now, there's a function which is given to us, fn, okay, and the function is also written down for us. We are asked to use mathematical induction. Now, I have deliberately chosen this question because I have seen that many of you are not able to actually use, although you know how to or what mathematical induction is, but it becomes difficult for you to apply it in the questions, right? So we'll try and use mathematical induction in this question and try to prove this. It's a medium difficulty level question. I won't say it's very easy. I won't say it's very hard. It's a medium difficulty level. So that's why this question is kind of an important one, we may say. Now, before beginning with mathematical induction, let's see what we are supposed to do. That should be very clear in your minds. So what we do is, in this case, there is fn x. Okay, there's some function of x which is given, which is x by 2 to the power n minus 2 to the power n minus 1 x, right? And we have to show that f of, we keep going like that, that is composite function, and n times of x should be equal to fnx, right? That's what we have to prove. Remember, f of x is x by 2 minus x, right? Okay. In mathematical induction, what you do is you take n is equal to 1 and you see if the proof exists. That is, if this is true for n is equal to 1. Let me use a different ink over here, so that it's very clear for you all to see this. So basically, when we are talking about induction, we take n as 1 and see if it is true. Okay, that's the first step. Second step is we take n is equal to k and assume, now this is very important, assume it to be true. That's the second step. Third step is we take n as k plus 1 and again we check if it is true. Now here is the link. When you are doing the third step, that is when you are checking for n is equal to k plus 1, remember you will have to, in most of the cases, you will have to use n is equal to k, which is your assumption. Okay, you may have to use the result which you got from n is equal to k because you have assumed it to be true. When you apply it over here, that's where the induction comes in and you prove that it's true. Okay, so maybe with this question, it will become more clearer. So let's check this out, whether n is equal to 1, we get this or not. So let's put n as 1. What do we get? f1 of x. We should get f of x, right? Let's see if we are getting that. X by 2 to the power 1 minus 2 to the power 1 minus 1 x, which gives us x by 2 minus 2 minus 1 is just 1. So 2 minus x, which is our f of x. So fn of x, sorry, f of x n times should be equal to f of x, which is what we got because our f of x was x by 2 minus x. So it is true for n is equal to 1. Next step, this was our first step. Second step is we assume it to be true. What to be true? This function, okay? To be true, it to be true for n is equal to k, which means f of k of x will be x by 2 to the power k minus 2 to the power k minus 1 of x. Correct? Right? So this is assumed to be true. Now comes the third part, which is we have to check if this is true for f of k plus 1 x. Now what should f of k plus 1 x be? It should be x by 2 to the power k plus 1 minus 2 to the power k plus 1 minus 1 x, right? This should be our result. Let me highlight that. We have to see by using induction whether we get this result or not. If we get this result, that means it's true. Okay, how do we use it? So we know what are we doing basically? What is fn or fnx? It's basically f of x n times, right? Which means, now see, if we have to find fk plus 1 of x, what will it be? It will be f of k of x. Is this part clear? I hope so. See, when you're finding f of x, what do you do? So it's like 2 times, right? F of f would be 2 times. So if you have to do it k plus 1 times, it will be f of fkx, correct? Which means in the function, remember how do we do composite functions? We remember the step which we did in the previous example. What did we do? We took, instead of x, we put f of x in the function, correct? That's what we are going to do. Instead of x, we will put f of kx in the function, right? Okay, let's do that. So f of k of x, okay, that's what we are trying to do here. Now, instead of x, we will put fk of x, which is x by 2 to the power k. You have to be very, very careful with the process over here. So this is your x. It's x by, right? Instead of, now, what's the function? It will be 2 minus, right? X by 2 to the power k minus 2 to the power k minus 1 x. Take some time to absorb this. Why do you think we did this? So what are we doing basically? Our original function is x by 2 minus x, right? When we do f of x, what do? We, instead of x, we put the f of x itself. When we are doing f of fk of x, what do? Instead of x, we put fk of x, which is this. And instead of 2 minus again x, we put again fk of x, right? That's what we have done till now. Because we are finding f of fk of x, which is fk plus 1 x. And our result technically should match this. If it does, then we have proved it using induction. Okay, now we'll do the same thing, which is the numerator, which is x by 2 to the power k minus 2 to the power k minus 1 x will remain as it is. The denominator, you take 2 to the power k minus 2 to the power k minus 1 x common. You're left with 2 multiplied, because it's like 1, right? Common denominator concept. 2 gets multiplied with 2 to the power k minus 2 to the power k minus 1 x, right? And then there is a minus x. Okay. Let's solve this further. So basically the denominator gets cancelled. So we are left with x from top. And let's see what we get in the bottom part. We get 2 to the power k plus 1. Because it's 1 over here, multiplied by 2 to the power k will be 2 to the power k plus 1. Minus, again, I'm opening the bracket and multiplying this. What do I get? 2 to the power k plus 1 x, because there's an x over here, minus 2x. And then there is a minus x outside. Correct? Minus and minus will be plus, so this will be plus. My bad. See, there is a minus and there is a minus, so these two minus will get cancelled out, we'll get a plus over here. So it will be plus 2x minus x. Then, next step. That's why I said you have to be extra careful, because you're not allowed a calculator. So even more careful. So x by, now we have, see, keep an eye on what result you want. At the end, you want 2 to the power k plus 1. So you want it outside, keep it outside. 2 to the power k plus 1, we have already got it. Next, what you want is, you want to take, so 2x minus x is just x, basically. So you can just write it as x. Then, next you want is a negative. So take negative common. What will you be left with if you take x also common? You will be left with a 2 to the power k plus 1 minus 1. Which is, so this is f k plus 1 x. Hence proved. So by induction, this is what we should get. And when we actually do the f of fkx, we actually get that. So therefore, we proved that yes, by using mathematical induction, this result is true. That's where I'm going to stop today. I hope you understood this whole method of using or applying mathematical induction. Please don't forget to like and subscribe the videos for further update on any further videos. Thank you so much. Bye-bye.